Brian Steglitz. I'm the Water Treatment Services Manager for the City of Ann Arbor. We're standing in the filter gallery of the City of Ann Arbor's water treatment plant. This is a 50 million gallon per day capacity lime softening plant that uses mixed media filters as well as ozone as its primary disinfectant. Is that the same sealer that we use for both drinking water and?
Yes. I'm Wendy Schultz and I'm the Environmental Lab Supervisor at the Water Treatment Plant. We are looking at heterotrophic plate counts. These counts are used on the distribution system of the water that's feeding into the homes of Ann Arbor, and it gives us an idea of the amount and types of bacteria that we're finding inside the distribution system.
Hi, I'm Mike Culpepper. I'm a water utility supervisor here with the City of Ann Arbor at the drinking water plant. What I'm doing today is setting up co-alert samples, which test for coliform and E. coli within the distribution system. This is the most colorful one that we did. You count the number of large cells that are yellow, and then you count the number of small cells that are yellow. All of our samples that are ready to come out after 24 hours are still nice and clear. They have no yellow color to them whatsoever, which proves that we have no total coliform. If they did show up as total coliform, then we would take them. If they were yellow, we'd take them over and we'd put them underneath a black light. And if the black light shines on them and they fluoresce, that would let you know that it's E. coli. We do this every day. One of the checks that we do here to keep the water safe and keep our residents happy.
So we're in our control room right now. A couple of unique features about Ann Arbor is on this screen over here. You can see we have 4 dams that we are able to operate from the water treatment plant remotely. 2 of our dams have hydropower. So in addition to drinking water, we're also responsible for power generation on the Huron River. So that's a unique feature that a lot of utilities don't have involvement with. So we're managing the power output from our hydros here. Our SCADA system, our supervisory control and data acquisition system, which is really the brains of the operation. We have, all the data comes in here, the control room, so the operator is able to control and see what's going on. We're also able to monitor our distribution system, and you can see some of the graphics here are actually photographs of some of our features, like for example, our elevated storage tanks. So we took a lot of pride in putting this together and actually using realistic representation of our assets in the building of this system.
And the flows that are cording in auto, because we were able to tie in the Ethernet down to the other computer, other PLC.
We just recently finished an upgrade of our programmable logic controller for the hydro. This is the computer control for the hydro. It allows us to interact with a lot of the features. We can see what the power output is on the hydro. We can see what the flow in the river is. We can see the position of the gates on the dam, and then a whole bunch of diagnostic information on how the hydro is performing. So this has allowed us to really do a much better job of troubleshooting performance problems and also trending how the hydro is performing. So we can come down here and see what's happening if we're trying to figure out a problem with the unit. So we're standing at the base of Barton Dam. Barton Dam provides the impoundment for the city's drinking water system. So where drinking water intakes are in the pond behind us. The dam behind me also serves for power generation. So we're making power here and we're selling it back to the electric utility. We make just under a megawatt of power. The work that we were just demonstrating is we were exercising the gates. We do that routinely, so to make sure that everything is working properly. The gates function in an automatic mode, so based on the level of water behind the dam, the gates will open or close in order to maintain a constant level. So it's not something that's operated manually, but we operate it manually to make sure if there's a flood condition, the gates will perform adequately. So the Huron River is the primary source of drinking water for the City of Ann Arbor. We serve about 125,000 customers, and on an average day we produce approximately 14 to 15 million gallons per day of drinking water. So right now we're standing on top of Argo Dam, which is the second dam along the Huron River that the city is responsible for operating and maintaining. The Argo Cascades are a series of 9 drops that bypass the dam, and they go around to the left and they extend about a quarter of a mile downstream and then reconnect back into the main stem of the river. The city built these Cascades, which are a series of 9 1 to 2 foot drops that allow canoers and tubers and kayakers to not have to portage around Argo Dam, which they had to do prior to this. So this was a project that was funded by jointly between utility and park funds in order to create this amenity for, you can see people are tubing right along right now, for people to use, and also to address the need for people to bypass this as part of the canoe loop that people are used along the Huron River. I've been honored to be selected as a George Warren Fuller Award winner for Michigan for 2016, and I really owe a lot of the accolades to the City of Ann Arbor, my employer, and the staff. We have a wonderful staff of 30 people who work very hard every day to provide drinking water to our community and our customers. We're 24/7, 365-day-a-year operation, so there's always someone here attending to this plant and ensuring that we're delivering safe water to our 125,000 customers every day.